Okay, in this video, we'll be talking about negation of compound statements. We'll start with negation of. I'll have an and in between. So let's say I have two statements P and Q, and I have an and between them. So this is a compound statement, and I'm trying to see what its negation looks like. And we have seen this a couple of times in the earlier videos. This is equivalent to the negation of P or negation of Q. So when you distribute the negative over an and, it turns into a or, and you get the negative on both the statements. This is also called the one of the De Morgan's law. Very important law. You can say that these two are logically equivalent by making up the truth table for both of these and checking with that the two columns are same. The other negation you can have is negation of an and. It's very similar to this one. A negation of an or. Negation of a P or Q is equivalent to the negation of P and the negation of Q. So again, the De Morgan's law, it turns the or into an and. Next, I can also talk about negation of a negation. And yeah, as evident as it may seem, it is the original statement P. Again, you can do the truth tables for both of these statement patterns and check whether the column for this is as good as the column for this. Now, the interesting part is the negation of an implication. P implies Q. But even before doing that, you can consider this an exercise to prove that P implies Q, this statement, is equivalent to the statement not P or Q. Now consider this as an exercise. Make the truth table for P implies Q. Make the truth table for negative P or Q, and you'll realize that both of these come out to be the same in each and every scenario. So once we have this, I can say that finding the negative of an implication is as good as finding the negative of this statement, right? Because the implication is as good as this. So negation P or Q. This was as good as this. And now I can use my previous knowledge of a negation of an or, right? So if I write it over here, negation of an or gives you the negation of individual components, but with an and between them. And I can simplify this to say that negation of a negation is just my original statement P, and negation Q, I will keep it as is. So this is ultimately the negation of an implication. If you have an implication P implies Q, then the negation of that is P and not Q. So this is one important negation. And as you might suspect, the next negation that we'll worry about is that of a double implication. Negation of a double implication. But even from our previous knowledge, we know what a double implication actually is. A double implication is as good as an implication P implies Q and the reverse implication Q implies P. So if I were to find the negation of this, if I want the negation of this, it's as good as finding the negation of this and statement, where my individual statements are themselves implications. So now I know from my previous knowledge that what negation of an and is. It's a simply negation of individual statements. P implies Q, Q implies P, but with an or in between. The and turns to an or if you find the negative. And from the previous knowledge, we know what negation of an implication is. This is as good as P and not Q. I can show it over here. This is what we found. P and not Q was the negation of P implies Q. It's here. P and not Q. This is my first part. And then I have or. Now here I just need to replace P and Q with each other. So I just have a Q and a not P. So yeah, this is it. This is the negation of a double implication. It might look a bit convoluted, but if you go through the steps, it's very clear. Now, the next kind of negation that we might come across is using quantifiers. Quantifiers are something which we learned in the previous video, so let's kind of have a refresher for that. Quantifiers are basically of two types. You have a for all quantifier and you have a there exists quantifier. Universal quantifier, existential quantifier. So let's say you have a statement involving for all. So you have a for all, and then maybe you have a some statement P. And let's say you have an existential quantifier with a statement something something. So if you want to find the negative of this statement, negative of a statement involving a for all, this is equivalent to there exists. This for all turns to a there exists, and then you find the negative of the statement that is there inside this as this in this statement. So you find the negative of that statement, which might involve some of the previous knowledge, but that this for all turns to a there exists. And as you might suspect, if you want to find the negation of a statement involving there exists, then this turns to a for all, and again you find the negative of the statement within. So you find the negative of the statement within, and this gives you the negative of the whole statement. We'll do exercises based on this in maybe future videos.